Hi, this is Mrs. Lenorvitz, and this is a quick overview as to how to work through part one of When Did They Die? Now, the first thing that you're going to want to do is make sure you've done a good close read, marking up the introductory information on the first page. Here you're going to get introduced to our untrue news flash and information about Lake Champlain and Colchesterium. You want to pay particular attention to which one of these is your parent and which one of them is the daughter isotope, and link that back to what you know about radiometric dating. Once you've done that, you're going to be looking at the next page and you're going to find a big long data set here. Your job with this data set is to construct a graph that shows how Lake Champlain decays over time. So you'll notice that you have 3 columns of data. You have time in years, you have percent atoms of remaining of Lake Champlain, and you have percent atoms remaining of Colchesterium. So for this, you are going to be creating a scatter plot or a line graph. It's actually going to have 2 different curves to it. You want to carefully look at these 3 variables and make sure you're identifying which one of them is your independent variable. The independent variable, remember, is the one that lies down on the x-axis, and it's the one that doesn't depend on anything else. So you can think about this, time is not dependent on anything else. So time here is going to be your independent variable and is going to go on your x-axis. When you construct your graph, you want to make sure you're using how to construct graphs, so make sure you refer back to that. You'll remember that constructing graphs rubric, and again, we're aiming for achieving, headed towards extending. As you work your way through this document step by step, it's going to talk you through what you need to do. So the first thing you need to do is label each axis with the variable and units. That's identifying the independent and the dependent variable. The best type of data to graph, in this case, you're going to be graphing all of the data in the data table. You're going to need to determine the type of graph. In this case, we're going to be working with a line graph because you're doing numbers on the x-axis and numbers on the y-axis. And then just as you did for your timeline, your scale timeline, you're going to need to come up with a good, consistent scale for each of your axes. In this case, the difference here is instead of using time like you did on your timeline, you're going to be using your range, or the difference between the biggest and lowest data point, for the top of your fraction. And instead of measuring actual distance in centimeters, you're going to be using number of boxes or number of grids on your graph paper for the bottom of your fraction. Just like you did with your scale timeline, when you do that division of numerator divided by denominator, if you get a number that is an unfriendly number, challenging to count up by, you're going to round that value up until it is something that's easier to count by. You want to make sure that you're not rounding up so much, otherwise your graph and your data are going to be squished into a really small space, and you want your graph to be as large as possible. Once you've done that, you're going to plot all of your data points. You're going to include a key if needed, and then you're going to title your graph. So make sure you're using this checklist to help you out. 2 tips that I would make as you're making this graph is, first, I would graph time versus Lake Champlain and do that whole data set all together. As you go, because you have a large number of values here, I would use a little check mark next to each value as you've plotted it. So just check it right off on your data sheet, and that way you know you've plotted it on your data table. That's a good strategy whenever you're dealing with a data set or you're dealing with multiple steps in a science lab. Once you've plotted the number of Lake Champlain atoms remaining, go ahead and repeat the same process, graphing time in years versus number of Colchesterium atoms that are remaining. When you are finished, your graph is going to look something like this. I want to talk you through each of these steps. So your finished graph will look something like this. You want to make sure you're using that graphing rubric to double check that you have everything that you need on your graph. So I'm going to highlight a couple of things here. Notice, first of all, that on our x-axis, we have an axis label. So we have our variable of time, and parentheses are units in years. On our y-axis, we have our variable, percent atoms remaining, and in parentheses, we have our units of percentage. Second thing that's going on in this graph is, notice that we have a good descriptive title. You want to make sure that your title is describing the relationship between your 2 variables. And a good strategy is to take your y-axis label and restate it, insert the abbreviation VS for verses, and then take your x-axis label and follow it up. This one is a little bit more descriptive in that it says that it's the amount of Lake Champlain and Colchesterium in percent versus time in years. And then a third thing that's really important in this particular graph, because we have more than one trend that we're looking at, is we have a key here to indicate which one's which. On your graph, which you're doing by hand, you can do this in different colors. So you could use colored pencil, or you could do, for example, a dashed line for your Colchesterium to distinguish it from your Lake Champlainium. So make sure you have a good finished graph before you move on to part 2.